This video is going to focus on mixture problems and how to determine missing parts within these problems. So when we're thinking about mixtures, we're looking at combining things within. So the thing that I like to think of the most, or an example, would be like a Chex Mix. So you add your peanuts, you add your raisins, you add your M&Ms, you shake it all up, and you now have this mixture. And that's kind of what we're going to be looking at through multiple different types of examples. So this first example is looking at a dye. So we have a 20% dye solution, a 50% dye solution, and we want to mix to obtain 6 liters of 40% solution. So if we're putting all of this solution into a jar or a bucket, once I put the 20%, once I put the 50%, I shake it up, and I now have 40% solution and 6 liters. But within that bottle, I put 20% and I put 50%. Okay, so I don't know how much 20%, I don't know how much 50%, but I know that I put some of each into that bottle. Okay, so when we do, I think the best way to visually kind of put everything together is to construct a table. So we have our first element, our second element, we mix them together and get our third. Okay, and that's going to be kind of standard for all of these. So what we're going to talk about is going to change, but I'm always going to have one thing plus another thing, mix it together, and you get your third and final. So in this case, we're talking about 20%, 50%, and then our mixture, which is 40%. Okay, the next thing you're going to have is going to obviously be some sort of a measurement. So we know that at the very end, that 40% is going to be 6 liters because that's what the problem tells us. But we don't know how much of the 20% or how much of the 50%. So when we don't know something, we give it a variable. But we're not at the point where I can put a y in here and solve an equation that has 2 variables. So I don't want to put a y there, but I want to figure out how can I represent that 50% solution as an expression, but use the x and use the 6. So let's come back to our picture over here. So I know this whole entire thing is 6 liters. I know that right here is x for our 20%. So if I took that bottle and if I could take out the 20%, it would leave me with the 50% left. So if I took the 6 liters and subtracted out the 20%, which is x, it's going to be left with that 50% solution in there. So I'm going to represent it as 6 minus x. I don't know how many liters of 20%, but I know that if I took them out, 6 minus whatever that is would give me the remainder for the 50. Okay, so I have to have some sort of a percent solution here. I have to have some sort of a measurement. How much of each am I putting together? And now I have to figure out how am I going to combine those. So you do that, and you're going to do that as we work through all of these problems by multiplying. So I'm going to do 20% times x, which is 20% x, okay, or we could refer to this as a decimal, so 0.2x, okay, so however you want to do that. Do the same thing for 50%, so 50%, but now I want to times it by the whole 6 minus x, okay, so or that could be 0.5 times 6 minus x. And then the last one, I have 40% times 6, which we can do that math because there's no variable within that. And that's going to give you 2.4. Okay, so what does that mean now? So when we go to write the equation, we're going to look at this last column here. So when we first started talking about this problem, we said we're going to dump in the 20%, we're going to dump in the 50%, shake it up, and we now have 40%. So that means you're always going to take your 1 plus 2, and that's going to give you your 3. So my 1 is 0.2x plus your 2, which is 0.5 times 6 minus x, and that's going to give you your 3, which is 2.4. Okay, so that's the equation we're looking at solving, and I'm going to erase some of this so I can give ourselves some room to solve this. Okay, so we got 0.2x plus, now I'm going to go ahead and distribute when I rewrite this. So 0.5 times 6 is 3 minus, and then 0.5 times x is 0.5x equals 2.4. Okay, so that would be my first step. Now I'm going to combine like terms. So 0.2x minus 0.5x is negative 0.3x plus 3 equals 2.4. Subtract the 3. Get negative 0.3x equals negative 0.6. Divide by the negative coefficient. And you get 2. So x equals 2. Okay, so lots of steps so far. So we have to figure out how to represent each of the dies, and then we have to put it into an equation and then solve the equation. So x equals 2. Well, what did x represent? X represented the number of liters for the 20% dye solution. So the 20% dye was 2 liters. That means the 50% was this 6 minus x, which is 6 minus 2, which is 4. And then in the end, we had our 6 liters. And you can see that 2 plus 4 gives you 6, which it should. Okay, all right, let's look at another one. Okay, how many pounds of lima beans that cost 90 cents per pound must be mixed with 16 pounds of corn that cost 50 cents per pound to make a mixture of vegetables that cost 65 cents per pound? So think of those bags of vegetables that you get that are mixed vegetables. It's got corn, it's got peas, it's got carrots, and it's all mixed together. That's what we're kind of talking about, except we're just looking at 2 things to get our mixture. Okay, so our first thing is lima beans, and that's 90 cents. The second thing is corn, and that's 50 cents. And then our mixture is 65 cents. Okay, so we know the price for each. Now the pounds. So it doesn't tell me how many pounds of lima beans, so I'm going to give it an X. It does say 16 pounds of corn, so that's there. But then it doesn't tell me how much for the mixture. Okay, so this was lima, this was corn. Okay, so in the last example, I told you 1 plus 2 always equals 3. So then in other words, x plus 16 would give you 3. 1 plus 2 equals 3. Okay, so that's how I would represent that. So a little different than the last example. But now the same thing applies. You multiply as you move over. So this would be 90 cents times x. This would be 50 cents times 16, which would be 8. This is 65 cents times the x plus 16. And again, 1 plus 2 equals 3. So we got 90 cents X plus 8 for the second equals okay. All right, now let's go to solve it. So let's distribute here first. So I have 0.9. I'm going to eliminate that second 0. All right, so this would be 0.65x, and then 65 cents times 16 would give you 10.4. Okay, now I'm going to get the x's on the same side. So I'm going to take this one over. So 0.9 minus 0.65 would give you 0.25x plus 8 equals 10.4. Subtract the 8, which gives you 2.4. Divide by the 0.25, and you get x equals 9.6. Alright, so again, the x equals the pounds of lima beans. So then the lima beans would be 9.6 pounds. The corn we knew is 16. So that means the mix would be 9.6 plus the 16, which would be 25.6 pounds. All right, let's look at another one. This one's looking at cinnamon. So we have 16 pounds of brand M cinnamon was made by combining. So take note of that. So this brand M is our combination. 12 pound of Indonesian cinnamon and then Thai. Okay, so the Indonesian is our 1. The Thai is our 2. The brand M is our mix. Okay, all right. Okay, so it says, just gonna kind of fill in the pieces, do this a little, see what we can get. So 16 pounds, so that's here, 16 pounds. 12 pounds of Indonesian, which cost $19, with 4 pounds of Thai, that cost $11. Find the cost per pound of the mixture. So right there is our unknown. All right, so notice that in this one, our pounds are not the unknown. 12 plus 4 gives you 16. The price is the unknown. Okay, and because we know all the other 5 pieces, we just have one that's an expressional part. So if I go ahead and again multiply as you move across, so 19 times 12 gives you 228. 11 times 4 is 44, and x times 16 is 16x. Okay. Right, so that means 1 plus 2 gives you 3. So 228 plus the 44 would give me the 16x. So 228 plus the 44 gives you 272. Divide by the 16. And we get x equals $17. So this would be $17 per pound for that mixture once you put Indonesian and Thai together. Okay, so the last three were very good examples. So they were all very different examples. We had a missing piece. The expression we came up with was different. So they're good examples leading up to these. So I have three of these pause and tries. So we'll take these one at a time. So go ahead and pause it. Use the last three examples. And then hit play and come back and hear the explanation. All right, this example is looking at candy. So we got, is mixing candy worth, so the first one, second one, third one. Okay, so the first one is $6 per pound with candy worth $8 per pound. She wants to obtain 144 pounds of candy worth $7.50. All right, so there's my price. The 144 pounds goes with the mixture. Okay, I don't know these. So the first one is X. The next one would be the 144 minus X. So think of the same thing. Here's your big bag of candy. This whole entire thing is 144 pounds. If I take out the $6 candy, by picking them all out, it's going to leave you with the 8. So this would be 144 pounds. Subtract out the $6 per pound candy, and that's what we get. So I have 6x would be the multiplication. This would be 8 times 144 minus x. And then that one would be 750 times 144, which is 1080. So your equation would be 6x plus 8 times 144 minus x equals 1080. So this is 6x plus, go ahead and distribute, 1152 minus 8x. Okay. Now 6x minus 8x is negative 2x. Subtract the 1152. I'm going to move over here. So you have negative 2x equals 1080 minus 150. That's negative 72. Divide by the negative 2, and you should have gotten 36. So that means you would do 36 pounds of the $6 candy. You would do 144 minus that 36, and you would do 108 of the other. Okay. All right, very good. All right, here's your next one. Go ahead and pause it and see what you got. This is like the die one. All right, so we got a chemist needs 12 liters of 50% solution for an experiment. The stock room has 40% and 70%. How much of each solution should be mixed together to form 12 liters of a 50% solution? So this is 40% and 70% to get you your 50% as desired. Okay, so he needs 12 liters of that. And again, we don't know these, so it would look like that. Okay. So I'm going to change these to decimals. So 40% times x. Then we have that one. And then 50% times 12 would give you 6. So that's what the table should look like. Your equation would be the 40% solution plus the 70% solution, which would give you the 50% solution. All right, so let's solve this out by distributing. It's 8.4 minus 0.7x equals 6. Combine like terms, and that would give you negative 0.3x. Subtract and that gives you negative 2.4. So we're right here at this. Divide by the negative 0.3. So, and that gives you x equals 8. So you would need 8 liters of the 40%. You would need 12 minus 8, which is 4 liters. And that would give you your 12 total liters. Good. All right, and the last one. Okay, so this one, before you pause it and try this one, this is a good one to have in case you run across one of these in your practice problems. So if it says pure acid, that's a 100% solution. Okay, all right, so go ahead and pause it and try it, and then hit play, and we'll go over it together. Okay, so how much pure acid should be mixed with 2 gallons of 40% acid to obtain 70%? So we have 100%, 40%. We're going to mix those together to get our 70%. Okay, and then we have 2 gallons of the 40. All right, so that would mean your 100% is unknown. But then I know x plus 2 would give me my 70%. So that's what your table. All right, so now 100% times x is just x, or 1x. 40% times 2 is 0.8. And then the last one is that. So we have x plus 0.8 equals 0.7 times x plus 2. So let's distribute before we get the x's on the same side. And that gives you 1.4. Subtract. Now remember, when you do x minus this is 1x minus 0.7. So that would give you 0.3x. Subtract 0.8. And I have 0.3x equals 1.4 minus 0.8, 0.6, divide, and I believe you get a 2. Yep. So then you need 2 gallons of the 100% solution as well as 2 gallons of the 40% solution to get to your 4 gallons of your 70% solution. Very good. Mixture problems are difficult ones. Practice really does help. Organizing your thoughts in a table really does help. So you now have 6 good examples to refer back to when you come to your practice problems.